Yeah.
Yeah, you too.
Yeah.
Oh, I didn't see this.
Did you guys hear this talking?
Okay, all we have to do today is go over any problems, and then the test is on Monday.
Look, your bag is over there.
What is it?
Did you get
Yeah,
it
it's
in class?
I didn't see it there.
Oh, you got the muffler? Or that's there supposed to be.
I got that muffle. Oh, we're doing the middle of the Oh my god.
Yeah, I got the
Evan, so far it's taking for you.
So I made the test. There's like 26 limited problems.
26.
Phrases,
Hi.
A through Z.
Hi.
26 limited problems.
Okay.
And then you have a few questions on the derivative.
Can we use a shortcut?
Well, if it doesn't say anything, you can, but if it says use the definition of the derivative, then you have to use the definition. I'll just tell you right now, it says it. You have to prove that you can use the definition of the derivative.
Why do we need a proof?
Yeah, of course you can check your answer for sure, but nothing wrong with that. So derivative 2 and 3. Where's 2? 2. Can somebody steal it?
Who's seeing the Mr. Park?
I have no idea. Keeps disappearing. People are just taking off their desk.
What does it mean, Mr. Park?
Okay, derivative 2, problem number 5. I showed you guys how to do this yesterday. Boo. 5, D, and E. They're both the same except different. I will do one of them then, because they're both the same. Which one do you want me to do?
5.
D or E?
Yes.
Dog or elephant?
Elephant.
Okay. It says use power series. So the first thing you gotta do is you gotta know the power series. Boris,
Oh.
read it off your paper.
X plus minus x squared over 2 plus
3 or 3 factorial?
3 plus x.
I like, it's so funny when you pretend you know stuff.
Over 5 minus x 7 over 7.
And then you just take the derivative term by term.
1
1,
X squared.
x squared over 2
no, that's not factorial now.
over 3.
The 3's just cancel out.
X squared.
5x.
The 5's cancel though.
X is 6.
Oh.
Plus dot dot dot.
That's cool.
Yeah, but Mr. Park, that's not the answer on the bottom. Yeah, that's because you gotta simplify this. Hey, you somebody, huh? Isn't this an infinite geometric series?
Yes.
Oh.
And how do you find the sum of an infinite geometric series?
1
First term over 1 minus r. What is the common ratio here? Negative x squared. And so you get 1 over 1 plus x squared.
That's right.
And problem D is the same thing too. You get an infinite geometric series, except the common ratio is different. Isn't that beautiful?
Yes.
See how it all comes together? And everybody got number 4 then, because that's the kind of stuff you gotta do on the test. You gotta find the pattern. You go? And then D3. Okay, I don't have D3. Who has D3? Number 35?
3 and 5.
3. It says, when is the derivative negative and when is the second derivative positive? 4x cubed minus x to the 4. I forgot what I just said earlier. 4x cubed minus x to the 4. Okay, so the first step is you take the first derivative, which is
4 12x squared minus 4x cubed.
Okay, right now you have no idea how important this skill is. You have to be able to tell when the derivative is positive and negative, and same thing with the second derivative, because there's going to be theorems dealing with that next year. So how do you determine whether a function is positive or negative?
You make the factor.
Yeah, you got to factor it and then you make a number line. So what can be factored out?
4x squared.
4x squared, what's left?
3
Minus x. You make a number line,
0.
0 and 3. Think of a number bigger than 3.
4.
Plug it in.
Negative.
Negative, and how do I know that it's going to go plus plus?
Square.
Because you have an odd power on this, so it's going to change sign here. You got an even power on there, so it's going to stay the same sign. But even if you don't know anything, just plug in numbers, right? So what are we looking for? Less than or greater than? Less than, so then the answer would be from 3 to infinity, then, right? And then now the second derivative. So the second derivative is
24x
20.
minus 12x squared.
what can be factored out?
12x.
12x, 2 minus x, number line,
0 and 2.
0 and 2. How do I know it's minus plus minus?
Plug in, and then it's all 1.
Or just think of the graph, it's a parabola opening downward, right?
Yeah.
So it's going to be below, above, whatever, just do it. And what are we looking for? Greater than 0 or less than 0?
Greater than.
Greater than 0, so between 0 and 2 is the answer. That's how you're going to be doing that all year long in calculus, making number lines. Except lots of times it's not going to be polynomial. You're going to have trig functions, exponential functions, logarithmic functions. And then number 5, is that the finished proof? Sounds like you're reading it for the first time, Freitas. Okay, you guys are going to have to read it because somebody stole my copy. Are you sure that's only questions? Okay, one last look. Yeah, somebody stole it already. Okay. Now what we are doing in number 5, see this is a taste of BC calculus. This is the difference between BC and AB. BC you actually prove things mathematically. AB. So what we're doing is, if you have a product of two functions, if you take the derivative of this, can I just take the derivative of the first times the derivative of the second?
Maybe.
No, the answer is no, you can't. Okay, and right here, we're proving that right here. Okay, so to compute the derivative, what do? Limit h approaches 0, f of x plus h, so you substitute x plus h into the function, minus f of x, all over h, right? That's the difference quotient, and then you take the limit as h approaches 0. Now the hardest step in this proof is the next step, but then I gave it to you right here. Okay, now what did I do? What did I do to get from this step to this step? All right, let me write it down. X plus h, g of x plus h, minus f of x, g of x plus h, plus f of x, g of x plus h, minus f of x, g of x. What did I do to get from this step to this step? Multiply by the conjugate. Look for friend. No! I just look, I subtracted gorilla and added gorilla. Aren't these two things the same except opposite signs? So is that legal? Can you subtract gorilla and add gorilla?
Yes.
Yeah. Now, why would somebody do that is because now, okay, let's lomi this. Look at the first two terms. What can be factored out from the first two terms? G of x plus h, and what's going to be left?
X plus h
Minus f of x all over h, right? Hey, you somebody. Now look at the third and fourth terms. What can be factored out? A negative f of x. No, a positive f of x. And what's going to be left? G of x plus h minus g of x all over h. Hey, You somebody! It's a movie, what? You gotta be joking. Okay, now let's apply the limit. What happens when you plug in 0 for h right there? No, it goes to 0, people. You get g to the x. G of x. G of x. And then, hey, what happens when you take the limit as h approaches 0 of that? That's the definition of the derivative. No. No. F prime of x. That's the derivative of f. That's the definition. Plus f of x. So what are you talking about definition? And then, hey, you somebody. That's the difference quotient. What happens when you take the limit as h approaches 0? You get g prime of x. Boom. So, if you have a product of two functions, to take the derivative, you cannot just take the derivative of the first and then the second and multiply them together. You have to use this. This is called the product rule. Here, let me give you an example. Now that we've learned it, now you're responsible for it on the test. Compute the derivative of this. This is probably a homework problem later. You're just not going to do it now. Oh, it's easy, Mr. Park. Take the derivative of this, which is 2x. Then you multiply it by the derivative of e to the x, which is e to the x, and that's the answer. No, you just got a fatal error. You cannot do that. What did we just go through? You can't do that. You have to use the product rule. If you have a product of two functions, to take the derivative, you use the product rule right here. You guys understand this product rule? Look. Here's the first, here's the second. Derivative of the first, leave the second one alone. Then you take the derivative of the second, leave the first one alone. And then you add them together. This is called the product rule. Basically, you just take turns. Derivative of the first. 2x. Leave the second one alone. Now take the derivative of the second. And leave the first one alone. There you go, that's the derivative. Whenever you have a product. Oh, so now that we know this, oh, the problems I can give you now.
What if you divide by 3?
By what?
1.3.
Oh, if you have 3 of them, then you use the product rule for 3 things. You take the derivative of the first, leave the other 2 alone. Then you take the derivative of the second one, then leave the other 2 alone. Then you take the derivative of the third one and leave the first 2 alone. You just take turns. That's how the product rule. So now here, f of x is equal to sine 2x. Compute the derivative. Was this the class we actually learned how to do this?
Yes.
Okay, judging from your looks, no. Now, what's the identity for sine 2x? 2 sine x cosine x. See, look. It's a product of two things, so you use the product rule. Now, so when you take the derivative, this is a constant, so you throw it on the side like an unwanted pet. And then since you have a product here, you use the product rule. Now, how does the product rule work? Derivative of the first. Yeah, I know, but you gotta tell me what it is. Wait, leave the second one alone. Plus, now you leave the first one alone, times the derivative of the second, which is negative sine x, and I hear Morris saying something. That's 1. Cosine squared x minus sine squared x is 1. Oh God, that's just so. Oh, no. Wait. This is so funny. We got it on video. Cosine squared x plus sine squared x equals 1. So therefore, by Morris's reasoning, cosine squared x minus sine squared x is negative 1. That's just funny. Okay, so what have we got here? Cosine squared x minus sine squared x. Hey, you somebody. That's cosine 2x. No, we did this in this class yesterday, didn't we?
No.
Yes.
No, you didn't.
We did this yesterday. Remember we did a power series problem yesterday? F of x. Wasn't this on the homework?
No, you
This
said,
was a homework problem on
you
that.
said it was on the homework, so we'll do it different.
Yeah, but it's the same thing, it's the same principle. What's the okay, we know the derivative of sine x is cosine x, right? So what's the derivative of sine box? Is it just gonna be cosine box? No, because I left the space in the front. 2x. What's
So
the,
this is the derivative of.
yeah, because that's the derivative
Yeah,
of
we
the,
did talk about this.
yes, we did. So, if you have sine box, the derivative is gonna be cosine box times the derivative of box, which is 2.
Yeah, we did talk about it.
Yeah, we did talk about it. But you guys can't even remember things 23.5 hours ago. So is that all? And look, this year we're not going to even do the quotient rule. That's probably the most fun. You got the product rule, and then of course there's a quotient rule, but we're not going to do that. But should I teach it to you anyway? Yeah.
Siri, yes.
What, just put it off to next year? Why would you say that when you can learn something?
Wait, was the quotient rule? What was the number 7?
What if somebody said, okay, here's more money, do you want it? Oh no, that's okay.
I'd love to learn that.
Are you sure? Now is the time to ask. Okay, I'm just going to give you a sample problem. Some sample problems. Then. Oh, here it is. Nobody stole it. Yeah, I just forgot I put it there. Okay, let's do some sample problems. Now, the first 26 problems are limit problems. They're all going to be mixed up now, so you got to know the difference between non-zero over 0, 0 over 0, infinity over infinity. You got to know what to do when you see a problem. Okay, let's start off easy. Let's start at the very beginning. A very good place to start. When you read, you begin with. When you sing, you begin with. Okay, here. You're not going to get a problem easier than this on the test. Okay, don't look at the cosine inverse. Just look at the thing in the parentheses. What happens as x approaches infinity? That goes to -half, right? Because if the degree of the top and the bottom are the same, you just look at the coefficients. So therefore, the whole thing gets closer and closer to cosine inverse -half. 2 pi over 3. It's probably going to be all or nothing 2 points each. There's no sense making 3 points each because some of you might be out of the game already in the first page yet.
Yeah.
And of course, is there going to be like one problem where you just plug in the number and get something? You wish. What's the limit? Here, I'll make it easy for you. What's the limit of x approaches pi over 8 tangent x then? If you can plug in the number and get something, that's the answer. Okay, plug in pi over 8. Morris, redeem yourself. 1.
Pi over 4
So 1/2 then.
No, it's a half identity.
Okay, math people, we should just know. Read out. Wang? Anybody? Yukawa. Pretend like you're paying attention now.
Yeah.
Mr. Park, can I just leave like your answer like that? Yeah, except you're not going to get credit for it because you got to simplify it. So pi over 8, what do I do? Write somewhere difference or half angle? Yeah, so you got to write it's half of pi over 4 now. What's the identity? They've got 3 identities.
1 minus cos.
Don't use the plus or minus 1. 1 minus cosine theta over sine theta. How many points do we get for that, Mr. Park? Nothing! 1 minus, what's cosine of pi over 4? 1 over root 2. 1 over root 2. Multiply top and bottom by root 2 and you get root 2 minus 1. Hapata! I'm skipping down. Okay, let's see how good you are. Limit. H approaches 0. E to the x plus h. minus e to the x all over 8. Let's see if you can make a connection here. Yeah. The derivative of what? Yeah, so the answer is e to the x. Look, f of x plus h minus f of x over h. Isn't this the difference quotient? And so if you take the limit as h approaches 0, doesn't that give you the derivative? Well, what am I taking the derivative of? This is f of x there, that's why. The derivative of e to the x is e to the x. Okay, let's try another one. Limit h approaches 0. X plus h to the 10 minus x to the 10 all the way. I remember I put a problem like this either last year or 2 years ago. And you know what they do? They expand it. It's the part, I know the binomial theorem, I remember it. No, you just look at that. This is the derivative of that. So the answer is 10x and a 9, finish your A's. Of course, if you do expand it, you'll get the same answer. Here, I'll give you a hint. Whenever you see limit h approaches 0, that's probably going to be the... Okay, we got some liquid on the board. It's erasing. There, it's all done. Okay. So, okay. Derivative. What other limit problems can I give you? You guys know them all already, right? And Peppo, Lomi, power series. Okay, here. Silence. Limit. Aye.
Friend.
Limit x approaches 0. I don't know. 10 inverse x minus x all over x cubed. How's that then? Okay, the first thing you do is plug in the number.
No.
0 over 0. So when it's 0 over 0, what do? You simplify it, look for friend, multiply by the conjugate, use power series. You gotta do something. Okay, very good. Well, how do you know power series? Okay, tan inverse. Okay, Morris knew this one, right?
X minus x to the third over 3 plus x to the fifth.
Plus minus x all over x cubed. Oh, but the x is cancelled. And then when you lift and separate, what's the first term going to be? Negative 1/3, and then all the other stuff is 0. See how power series bails you out? And power series is good. Power series good. Fire bad. Okay, what's another one? Limit x approaches 2 from the left. X minus 1 over x minus 2. Now, when I put from the left, it's kind of like a hint already, yeah? Well, maybe not. What's the first thing you do? You plug in the number. What happens when you plug in 2? You get 1 over 0. What does that mean? That means there's a vertical asymptote. That means the answer is going to be either plus or minus infinity. It's a 50-50 shot. So plug in a number very close to 2 on the left, like 1.999. 1.999 minus 1 is positive. 1.999 minus 2 is negative. Positive over negative is negative. So when I put from the left to the right, it's kind of like a hint that probably this is going to be a vertical asymptote there, yeah? You know what I'm talking about?
When you're doing
Unless there's not.
a circle, how do you know what's on the left and what's on the right?
Say that again?
When you do like the circle, like the cosine ones, you know like how it's like negative.
Oh, here. Okay, let's do a trig one. What's the limit? As x approaches, give me something. Pi over 2 from the left. No, from the right. 1 minus sine x over cosine x. Something like that. No! Plus. Okay, what happens when you plug in pi over 2? You get 2 over 0. That means there's a vertical asymptote there. So that means the answer is going to be plus or minus infinity. It's a 50-50 shot. Okay, so you gotta plug in a number very close to pi over 2 on the right, so pi over 2 plus a little bit, which means it's gonna be in the second quadrant, right? So what's the sign of a second quadrant angle? So 1 plus positive is positive. What's cosine of a second quadrant angle? Negative. Positive over negative, negative infinity.
Wait, why did you go that way instead?
Because pi over 2 on the right.
Oh, okay.
But it,
Yeah, but the
It's
circle
on the left.
but the circle goes like this
Yeah.
though.
so if it was on the left.
Yeah.
Okay.
Go non-zero over 0. You guys know how to low me, and hooly, right? What's that? N to the n cap. Well, come on, you guys can handle it, right? So we're done then?
Yeah.
Okay, so the test is on Monday. Starting Tuesday, we are going to review for the final exam. Do not come to class unprepared.
Wait, Mr. Park, we don't even know all this stuff from the beginning.
Wait, I'm not finished there. What?
We don't even know this stuff from the beginning of the year.
No, just second semester. But you're gonna have to know all your base graphs still. You gotta know all your trig values and identities still.
Like, we can forget logic. Right?
Yeah, you not there won't be any logic.
Ever, right?
Thank the Lord.
Yeah.
When you take the LSAT,
You know what that is?
Wait, what is that?
if you want to go to law school,
I don't need to want to go to law school.
well, some people do. And when you do, they're gonna say, "Oh, Mr. Park, I remember my logic was so easy for the test." A lot of people come back and tell me that, but not this guy. What's contrapositive?
When you turn both of them negative and you flip them.
Okay, we're done. We're done. Okay, you have 17 minutes remaining.
Okay, so Alex, it's this guy. Did you make any progress on that?
You start writing that.
You changed. Oh my god.